Hello, students. This is your professor, Mr. Camacho again. And today we have another exciting and great topic in mathematics. I can say sometimes that is the most important, one of the most important topics in algebra, quadratic equations. Quadratic equations are also called second-degree polynomial equations. And that is the first question that you have in your assignment. In the assignment that you have to do as a homework says quadratic equations are also called, and the answer is second degree polynomial equations. Why are called second degree? Because as you can see in the examples I put there in the wall, all these equations, the degree of the equation is 2 because the exponent 2 is the highest power in the equation, and because that are called quadratic equations and are generally written in the form of ax squared plus bx plus c, where A, B, and C are coefficients, means are real numbers. And you know already the C is called a constant because that is the only one that don't have a variable multiplied to the letter. And also are in standard form because are in order, because the first term is to the power of 2, the second term is to the power of 1, and the constant is to the power of 0. So when you see that the powers are set in a perfect descending order, we call a standard form. What are the methods that we can use to find the solution for these equations? Well, first one is factoring. That is the reason when we start the semester and we touch factoring, I told you that will be a very important factor to learn because you will use factoring for the rest of the semester, and I can say for the rest of your academics until you graduate. We can solve using the quadratic formula we have done before. Completing the square, we have not covered that. It's not covered in this assignment. And probably I will create a video of completing the square itself will be in my archive and my lecture notes and videos for whoever are interested to know how to complete the square of an algebraic expression. And the other way that we will do the next, probably next month, is graphing. We have to graph a quadratic equation. The default, all the quadratic equations graph has the shape of a parabola. And the pairing formula is like this. That is your y-axis and your x-axis, and that is the shape of a quadratic formula. We have to graph, but the graph will change as we manipulate the equation. And then forms of quadratic equations, we have a standard form, as I said, no, x squared plus bx to the 1 power plus c to the 0 power. You see the powers are in descending order, and that is called the standard form. Or another way to do is called I forgot to put the power of 2 here. It's called the vertex form. And when we were graphing equations, quadratic equations, we would have to use this vertex form to know where is the vertex and where is the line of symmetry of the parabola. And also factor form. No a, no times x minus r times x minus s. And that will reveal to us the x-intercepts. What are the x-intercepts? Well, that again, this picture will change as we manipulate the formula, but a parabola could be something like this too. And you can see the arms of the parabola are crossing the x-intercept in these two places. And when we work with the factor form, we put the factors to 0, will give to us the values of x, and then we can pinpoint where the arms of the parabola are intercepting the x-axis. Well, that is the introduction to this class. I hope that is helping you to understand about the quadratic formula and all the implicances with algebra. We will use this equation over and over and over, as we also have to use factoring and the quadratic formula. Let me erase that. I'm recording this video so you can come and you can watch this again and over until you can understand anything that you need to know about the quadratic formula in order to do your assignment, your homework, and take your quizzes, and also have a good grade in the exam. So let's see an example of quadratic formula. My first example of the quadratic formula is x squared minus 18x equals 0. So again, that is a quadratic formula. How I know that? Because the greatest power in this equation is 2. Because this x to the second power, the second x is to the 1 power. So because have the highest power is 2, we call it a quadratic equation. And we need to simplify, we need to to the lowest terms. And we need to use factorizations. So we have learned 4 ways to factorize, or 5 if we count the quadratic formula. But normally we learn to factor taking the great common factor, the GCF. Also factoring by grouping, or when it's a quadratic trinomial with leading coefficient 1, we take the shortcut. Or when it's a difference of 2 squares, we take the shortcut. And when it's a quadratic trinomial with a leading coefficient greater than 1, we split the middle term in 2 numbers. And because we have 4 now, we can solve factoring by grouping. But what would be the best way to do one? Well, you can see that it's not a difference of 2 squares because you cannot take the square root of 18. But definitely, I can use the method of taking the great common factor, the GCF, the great common factor. And what is the great common factor? Is a factor in this equation that can divide evenly both terms. And I can see that both terms have an x. So I will factor an x outside. I will factor my x, open parentheses. And when you do that, you start dividing. Now remember that the leading coefficient of any variable that don't have a leading coefficient by default is 1. And if they don't have a power, the default power is 1. So as we start dividing, you have a 1 here too. 1 divided by 1 is a 1 or an x. And then we subtract the powers because we are dividing. When we multiply, we add the powers. When we multiply, we add the powers. When we divide, we subtract the powers. 2 minus 1 is a 1. And then negative 18 divided by 1 would be a negative 18. And then this x to the 1 and x to the 1 cancel because 1 minus 1 is 0. So that is my answer. My answer would be x times x minus 18. That will be the answer for question number 1. And you can see, as we said in the beginning, one of the ways to solve this equation is by factoring. So let's go and put equation number 2. Equation number 2 that you will see in this equation, in this homework, will be x squared minus 36. All right, you can identify this binomial, x squared minus 36. Of course, I heard somebody said it's the difference of two squares. Sure as this. And it's also in your and if you go back in your assignment that we did before, we have a lot of these cases. So why is called a difference of two squares again? Because you can take the square root of x squared and you can take the square root of 36, and both terms are being subtracted. That is the reason it's called the difference of two squares. To solve this, we open parentheses because we can do the shortcut. No, you put an x here and an x there, and then the next step that we do is we will take the square root of 36. The square root of 36 is 6. And then by convention, the first parenthesis is positive, the second is negative, and that is the answer for question number 2. Again, we use factoring again to solve the quadratic equation. Let's go to question number 3. Or example 3. You have x. Oh, so example 3, let's go to 7x squared minus 13x minus 2 equals 0. All right, you can see that this is a quadratic trinomial. Because why is a trinomial quadratic? Because the maximum power is 2. The degree is 2 because this x is to the power of 1 and this 2 is to the power of 0. So in descending order, it's an equation in standard form, but it's a quadratic trinomial. It's a trinomial because it has 3 terms. No, you have 1 term, 2 terms, and 3 terms. This is a quadratic trinomial, but the leading coefficient is not 1. So we cannot do this shortcut. How we solve this problem? Well, first of all, we have to multiply -2, the constant, that is the constant, we mentioned this name in the introduction, by the leading coefficient. The leading coefficient. And the leading coefficient is 7. So we multiply -2 times 7, and we get negative 14. So it's the way that you solve a quadratic trinomial with leading coefficient greater than 1, we need to split the middle term in 2 terms to have 4 terms and then be able to factor this problem by grouping. How you split the middle term in 2? Well, we already multiply the constant and the leading coefficient, and the number is -14. -2 times +7 is -14. I need 2 numbers that when I multiply them will give me -14 as a product, but when I subtract these numbers, same numbers, will give me -13. And I heard somebody say 4, 14, and 1, of course. No, but which one has to be negative? Which one has to be positive, 14 or 1? Well, remember the law of signs, when you subtract 2 numbers, no, a negative and a positive number, always the answer will carry the sign of the bigger number. So who is bigger, 14 or 1? Of course, 14. So it has to be -14 plus 1 in order to have a -13. So negative, I will rewrite, let me go and rewrite in the top question 3 again, but this time let's rewrite it with 4 terms. So we still have in the front 7x to the square, but now it's no longer 13x, it's minus 14x plus 1x, you know, 14 -14 times 1 is -14, but -14 plus 1, so -14 times 1 is -14, but -14 plus 1 is -13, and that suffices the middle term is -13. and then negative minus 2. So I have now the same equation, but I split into negative 13x in two terms, negative 14x plus 1x. Now I will group this, the first two terms, 7x squared minus 14x to the 1 power. I will drop my 1, my plus sign, sorry, and then I will write here x minus 2. This is what I can factor out of the first group. What I can factor out of the first group that will be able to, that's question number 4. Let me do something more clear. Question 4. No, and of course, no, the only thing I can factor out will be 7x because 7 can divide by 7 and 7 is divisible by 14. So it will be 7x to the 1 power. Always you pick the variable with the lowest power. You have an x squared and an x to the 1 power. You pick x to the 1 power, the lowest power. And now start dividing. 7 divided by 7 is a 1 over x. And 2 minus 1, I subtract the powers. 2 minus 1 is a 1. No? Then negative 14 divided by 7 is a 2, is a negative 2, because it's a negative 14 and a positive 7 will be a negative 2. And then the 1 and this x and the 1 here, they when you subtract 1 minus 1, they cancel. So we have our first factor there. Then you drop your plus, and you can see that the same terms are in the first factor are in the next one, in the next group where we need to factor out. When you have something like that, you factor out a 1 and rewrite the same thing again. And now you have your equation. So now we will write out, first of all, the outside factor, 7x plus 1. And then my second factor could be any one of the two parentheses because have the same terms, x minus 2. So you can see we will be able to find out the values of this equation. Something that I forgot to tell in the beginning, is my fault. When you have an equation equal to 0, finding the factors is not enough. You need to find the values of x. So if you put x is equal to 0, that will be one value. And then you have a x minus 18 equals 0. You add 18 to both sides. And the second answer will be that x is equal to positive 18. So in the first question, 0 and 18 are the answers. I have these two answers, 0 and 18. No, then let's go to the next one, question number 2. You have two answers. You have a x plus 6 and x minus 6. So you have a x plus 6 is equal to 0. If you subtract 6 from both sides, x is equal to negative 6. And then you have x minus, let me do better, x minus 6 equals 0. You add 6 to both sides, and the second answer that will be that x is equal to 6. So the answer here is x is equal to negative 6, x is equal to 6. And in the last one that we have done in number 4, we need to set these factors to 0. 7x plus 1 is equal to 0. We subtract 1 from both sides, and then 7x is equal to negative 1. Then we divide both sides by 7. The answer is x is equal to negative 1 over 7. The next factor is x minus 2 is equal to 0. And if we add 2 to both sides, we have that x is equal to x is equal to 2. So that is the way that we need to solve these equations. We don't stop finding the factors. Then you have to set the factors to 0 to find out the value of x in every equation. I will give you a minute to take notes, and then we will go into more examples. More examples about the quadratic equations. Let me erase to be able to continue because there's no more space in the board. I need a bigger board, probably a TV that's 4 times this TV. I will erase everything to have more space to work in this smart TV. Well, the next question that we have is, I guess, question 5. Is we have a 4x squared. Let me do a better. 4x squared plus 9 is equal to 12. 12x, sorry. So you can see we have a binomial in the left side of the equation, and we have one term or a monomial in the right side, but looks like the 12x belongs to the left because you have the power of 2 and the power of 0, and that is the power of 1. This term has to be between 2 and 0. So let's move 12x to the left side, and to do that, I will have to subtract 12x from both sides. And then I can rewrite my equation as 4x squared minus 12x plus 9 is equal to 0. Again, I have a quadratic trinomial, but this quadratic trinomial don't have a leading coefficient 1. Because again, I have to multiply my constant 9 times the leading coefficient 4, both are positive, and there is 36, positive 36. So I need two numbers to split in two terms, negative 12x. The middle term, I need to split it in two terms to have 4 terms and then be able to factor by grouping. So I need two numbers that when I multiply them give me 36, but when I add them together give me negative 12. What numbers could be? And I heard somebody says loudly, 6 and 6, of course. No, because 6 times 6 is 36. And if we put a negative 6 times a negative 6, and we add them together, it's a negative 12. And negative 6 times negative 6 is a positive 36. So you have a 4x squared minus 6x minus 6x plus 9. Now I have my 4 terms equal to 0, and I will group the first two. 4x squared minus 6x, close parentheses, minus second group 6x plus 9 equals 0. So my next step is I will try to factor out the great common factor of the first parenthesis. And the great common factor, the only number can divide evenly 4 and 6 is 2. And then I will pick this 6 to the 1 power. This 6 is to the 1 power. So let's pick this 6 to be 2x to the 1 power. And then let's factor it. So 2x will be my great common factor, my GCF. And I start dividing. positive 4 divided by positive 2 is a 2, and then the power of 2 divided, the power of 2 subtracted by the power of 1, 2 minus 1 is a 1 or an x. And then it's a negative 6 divided by positive 2 is a negative 3. And the power of 1 and this x and the power of 1 here cancel, and the x is canceled out. Then I put my negative sign, and I need to find also something that I can factor out the first group. What number can divide evenly 6 and 9? And of course, the answer is 3. So you put your 3 and you start dividing. Negative 6 divided by negative 3 is equal to 2x. And then positive 9 divided by negative 3 is a negative 3 equals 0. Then we have our factors. My first factor is 2x minus 3, parentheses, and I can pick each one of the factors I have, and the other factors are the same. So I don't need to find the value of the other one because it will be the same value. To find the value of x, I have 2x minus 3 is equal to 0. And then I will add 3 to both sides. And I have the 2x, the 2x is equal to positive 3. And then I will divide both sides by 2. And when I do that, the answer that I get is that x is equal to 3/2. And that is the lowest terms of this fraction because 3 is a prime number. Everything that you see a prime number in an equation, in a fraction, if they want as an answer a fraction, that is as far as you can go. Let's try question number 6. Question number 6, we have to use another method to solve this problem. Let me put here Q6. You have x squared is equal to 169. So how we can solve this problem? Well, hold on, let's complete the square. Let's move 169 to the right to complete the binomial. So if I subtract, because it's positive 169, so if I subtract 169 from both sides, these two cancel together, and my new equation is x squared minus 169 is equal to 0, because the positive 169 and the negative 169 is 0 together. So let's see if that is a difference of two squares. What would be the square root of, what is the square root of x squared? Well, it's x. Does 169 have a perfect square root? Yes, 13. So I can do the shortcut because that is a difference of two squares. The square root of the first term, x squared, is x, and I put the x in every parenthesis. And the square root of 169 is 13, and I put 13 in both parentheses. The first always is positive, the second is negative. And I have my answer. That is the solution of this factorization, or that is the way that I was able to solve the quadratic equation by factoring a difference of two squares. But I still need to find the values of x. So I will take the factors out and set them to 0. X plus 13 is equal to 0. If I subtract 13 from both sides, x is equal to negative 13. And the second factor, x is x minus 13 is equal to 0. If I add 13 to both sides, these guys cancel, and the answer is that x is equal to 13. That is the answer for question number 6, that x is equal to 13 and x is equal to negative 13. Let's keep working other equations. And I will give you a minute, you copy and you take your notes, and then we're going to question number 7. Let me erase everything, and let's see a question number 7. What kind of quadratic equation is and how I can solve question number 7? So I have question number 7 is x squared plus 36. That looks like a difference of two squares, but it is not a difference because these two numbers, these two terms are being added together. To be a difference of two squares and do the shortcut, you need to have a negative sign between them. They need to be being subtracted. That is the reason we call the difference of two squares. That is not the case. So what we have to do in this case, I will first of all move 36 to the right side. So I will subtract 36 from both sides. And then these guys cancel, and I got x squared is equal to negative 36. Second, to find the value of x, my obstacle is this exponent 2. Well, we learned before that the opposite equation to raise a number to the second power is to take the square root. So if I take the square root of x squared, I need to take the square root of the other side. But before do that, the next thing I have to do is plus minus. No, I need to do my plus and my minus. And that will give me the square root of negative 36. The second obstacle that we have is that 36 have a perfect square root, but not negative 36. So to fix this problem, we need to use the I of the complex numbers. So you have the square root of x squared is equal to plus minus the square root of 36 times the square root of negative 1. And now we can simplify this equation. These two and these two cancel, since I have an x on it, is equal to plus minus, the square root of 36 is 6, and the value of the square root of negative 1, we already did that, is I. So you have two answers in this question. X is equal to positive 6i, and x is equal to negative 6i. And that was question number 7. See if we can solve 8 next to them. Question number 8. Let me go to question number 8. These papers are so thin, a hard problem. Question number 8. In question number 8, I have this equation. Q8, question 8, says x, let me do it again, x minus 7 squared is equal to 9. How I fix the problem? We have to do the same process that we did before. First of all, I'll do the opposite equation, and we already did that in question number 7, that the x was raised to the second power, and the only way to cancel the second power was taking the square root of x to the second power, because both are opposite equations. In this case, these numbers already rise to the second power. So to cancel this second power, I need to take the square root of this number. no? And that will be x minus 7 is equal, but before put anything in the right side, you have to put your plus, your minus, and then the square root of 9. So it's the 2 here, the power of 2 that x minus 7 is rise to, cancel with the index 2, both cancel because are opposite equations. So this guy cancel with this, and I have x minus 7 is equal to plus minus 3. Now, my next step is I need to move this negative 7 because I'm solving for x to find my answer. So to do that, I will add 7 to both sides. So yes, I know that x is equal to 7 plus minus 3. So this x have two answers. X is equal to 7 plus 3, that is 10. And x is equal to 7 minus 3, that is 4. And that is the two answers for this question. I'll give you a minute that you can take your notes, and then we go into question number 9. You can see, and we are very consistent using everything that we have learned until this point to be able to uh, to be able to simplify these equations to the lowest terms. Let me erase to go to question number 9. Question 9. Question 9 in our assignment have this form. Question 9, you have x squared minus 2x, oops, I want to write, minus 2x minus 2 equals 0. Alright, that looks like a quadratic trinomial with leading coefficient 1. And when you have the quadratic trinomial with leading coefficient 1, you can do the shortcut. But first we have to multiply the constant negative 2 by the leading coefficient 1. And when you got negative 2 times 1 is negative 2. Then you need two numbers that when you multiply them will give you a negative 2, but when you add or subtract these numbers will give you negative 2. And in reality, you can try. I tried. There is not a number. So therefore, because you cannot factor then taking the shortcut, we have to apply to this the square root. And the square root is negative b plus minus the square root of b squared minus 4 times a times c all over 2 times a. That is the equation. And now we need to label the numbers that will match these letters in this equation. This 1 is A, negative 2 is B, and negative 2 is C. So the only thing I have to do now is replace these numbers for the letters in the formula. Negative B will be negative, and remember it's a negative B. B is negative 2 already. It will be negative 2 plus minus the square root of negative 2 squared minus 4 times A. A is 1 times C. C is negative 2. And everything is over 2 times A or 2 times 1. So let's try to simplify it, cleaning up this equation. You have a negative and a negative will be a positive. So you have a 2 plus minus the square root of negative 2 is a 4. And then you have negative 4 times 1. Negative 4 times 1 is 4. 4 times negative 2 will be positive 8. And all over 2. So if I keep simplifying, I have now 2 square root 4 plus 8 is 12, and all over 2. Ahora, the challenge is 12 don't have a perfect square root. So I need to factor 12 in two numbers, or two factors of 12, and one of them must have a perfect square root. And I heard somebody saying very clear, 4 and 3, of course. So that is the same thing to say 2, no, square root of 4 times 3 over 2, or 2 times the square root of 4 times the square root of 3 all over 2. I forgot the plus and minus. Sorry for that. It's plus and minus, and here is plus and minus. So let's keep going one more simplification. I have now 2 plus minus, the square root of 4 is 2, times the square root of 3, and all over 2. Doesn't look like a 2. Now I can factorize the numerator because I have two 2's there. So if I factor 2 out of the numerator, I have 1 plus minus the square root of 3 all over 2. And finally, I can cancel this 2 in the numerator and this 2 in the denominator. And my final answer will be 1 plus minus the square root of 3. Or also, we can say 1 plus the square root of 3, or 1 minus the square root of 3. That will be the answer for question 9 using the quadratic formula. You can see quadratic formula is not complicated. You need to keep only things in order. In mathematics, you need to be organized, because if you are not organized, you will have a hard time. Let me give you a minute to copy that, and then I will go to the next one. So I erase this equation. The next, also, we have to solve using the quadratic formula. Question 10, we have to use the quadratic formula. You have question 10, and you have to use the quadratic formula because there is no other way to factor that. I tried every way, and you can try by your own if you want. And if you find any way to factor correctly this trinomial, a part of the quadratic formula, please shoot me an email with your idea. And the quadratic formula we already did is negative b plus minus the square root of b squared minus 4 times a times c all over 2 times a. So let's label these numbers to be able to replace by the letters. This a is your a. This negative 4 is your b. And this positive 1 is your c. So let's replace these numbers in the equation. So b is negative 4. And remember, it's negative b. And this b is already negative 4. So it will be negative 4, negative 4, no, plus minus the square root of negative 4 squared minus 4 times a, in this case is 8, and will be, and c, that is 1, all over 2. No, 16, because we 2 times 8. 8 is 8. So let's clear up this equation. Negative times negative 4 would be 4 plus minus the square root of negative 4 squared is 16. No, and then you have a negative 4 times a is negative 32 times 1 is negative 32. No, minus 32 all over 16. So let's simplify one more time. No, you have here 4 plus minus, and you subtract 32 from 16 is negative 16. Negative 16, and everything is over 16. But you know that negative 16 don't have a perfect square root because you cannot have a negative answer for a even index. No, it's the square root is a 2, is an even number. So I need to use the imaginary numbers to solve this equation. So you have a 4 plus minus, let me do again, 4 plus minus, and the square root of 16, no, times the square root of negative 1. And this negative 1 took the negative sign from the radical, or the radicand, sorry. Now you have a 4 plus minus the square root of 16 is a 4, and then you know that the square root of negative 1 is I, and all over 16. And we can keep simplifying this. We can factorize the numerator. I can put a 4. No, if I put a 4, I will have 1 plus minus I all over 16. And then I can cancel these 4. 4 go 1 and 4, and 4 times in 16. So my final answer will be 1 plus I plus or minus 1 plus minus I over 4. That will be my final answer. And I can also broken this in two fractions. That will be equal to 1, no, 1/4. I can broken two fractions plus I over 4, or even you can say 1/4. Well, let's keep it this way. Or could be also 1/4 minus I over 4. So that is the way that you can express your ideas. And remember, you have a 1I there. Have a 1I. So that is 1/4 plus 1I/4, and the other one will be 1/4 minus 1I/4. That is question number 10. Again, if you have any questions about what I'm doing, I encourage you very bad to shoot me an email and let me know your concern, what you don't understand. Because next week is the exam, and you better know what you're doing right now before the next week. They want to have a good exam. Question 11 is another quadratic formula. And I like to do quadratic formula because, the most that we do something, the less challenging it is to us, because practice makes things perfect. You have a square root, minus 6x, minus 4. And you know that the leading coefficient is 1, and the formula is negative b plus minus the square root of b squared minus 4 times a times c, and all over 2 times a. So let's label these numbers to be able to replace numbers for letters in the equation. This 1 is your a, this negative 6 is your b, and the negative 4 is your c. So let's start with negative b. But it's negative b, and there is a negative 6. So it will be negative 6 plus minus the square root of negative 6 squared minus 4 times a is 1, c is negative 4. Let me do a better negative 4. Negative 4, no, extend your radical sign, and everything is over 2 times 1. So let's start simplifying this equation. Negative, negative, and negative is a positive. So you have 6 plus minus. No, the square root of negative 6 squared is 36. And negative 4 times 1 is negative 4 times negative 4 will be positive 16. So you, and all together over 2. So what will be next? Well, I need to do my math. 36 plus 16 is 52. So you have now 6 plus minus the square root of 52 over 2. But we know that 52 don't have a perfect square. So I need to broken 52 in two factors that, doesn't look at 52. We have a 52. We need to broken down in two factors that can give 52. And the only factors I found that, and one of them have a perfect square root, would be 4 and 13. So it would be 6 plus minus the square root of 4 times the square root of 13, and everything is over 2. So let me make a line here in the wall to continue this equation. I don't have no more space in the bottom. So this, we have 6 plus minus the square root of 4 times the square root of 3 all over 2. So I can simplify one more step forward. 6 plus minus the square root of 4 is a 2, no, times the square root of 3 and all over 2. And I will try to factor something that can divide evenly the two numbers in the numerator. I have a 6 and a 2. And if I factor out a 2 from the numerator, now I have a 2, and then I have a 3 plus minus the square root of 3, and all over 2. Then these two in the numerator and the 2 in the numerator can cancel, and the final answer for this equation will be 3 plus minus the square root of 3. One answer could be 3 plus the square root of 3, and the other answer will be 3 minus the square root of 3. So you can see it's very straightforward. When you begin to get a mechanic, you are no more fearful for quadratic equations, and you can be able to factorize any number using the quadratic equation. Let me erase that. We are almost at the end of this assignment, but I hope that all these examples and all the explanation I'm doing will help you to understand how to solve quadratic equations. But let's do and two more, and we quit. Now, question number 12. Question number 12, you have a x squared minus 8x plus 17 equals 0. How we solve this equation? Well, the only way, again, quadratic formula. The quadratic formula again is negative b plus minus the square root of b squared minus 4a minus c, minus 4 times a times c are all over 2 times a. So let's label a number to replace it for the letters. The leading coefficient of this trinomial is 1, and 1 is my a. my B is -8, and positive 17 is my C. So let's replace this in the equation. It's negative B. This B is already negative. It's -8. The -8 plus minus the square root of -8 squared minus 4 times, let me do the 4 better, 4 times 1, that would be A would be 1, and C that is 17, and all over 2 times A that is 1. Do a better 1 there. Yeah. So let's simplify negative, and negative is a positive. So you have a 8 plus minus the square root, and you have a -8 squared is 64. No, minus 4 times 1 is -4, and -4 times 17. -4 times 17 is 68. So 64 minus 68, and all over 2. Let's simplify one more time. You have a 8, you have a plus minus the square root. 64 minus 68 will be a -4 over 2. And we know that -4 have a perfect square root, but no -4. So I need to solve this equation using complex numbers, the I. So that would be 8 to remove the negative out of the radicand, plus minus the square root of 4 times the square root of -1 and all over 2. If we simplify one more time, you have a 8 plus minus the square root of 4 is 2, and the square root and the square root of -1 is equal to I, all over 2. Let's go to the bottom of the page to finish this equation. So I will rewrite 8 plus 2I over 2. So I can factor the numerator, and that will be equal to 2. And then I have a 4 plus I, no, over 2, plus minus I, 4 plus minus I, all over 2. The 2 in the numerator and the denominator cancel, and my final answer will be 4 plus I, one answer, and the other one will be 4 minus I. And that is question number 12. Again, no, looks sometimes intimidating, the quadratic formula, but you can see it's simple. Only you need to keep track of your negatives and positive signs and do right your arithmetic. Even the quadratic formula that have nothing to do with algebra. See, we apply algebra in the end, the I in the end, but all the calculations is arithmetic. No. So let's put your notes and let's do our last question. I believe you will really enjoy our last question. Oh, there's no more question. Oh yeah, there's one more question. See what happens. So I will erase that, and the last question also involved the quadratic formula. And again, I'm happy that we can do so many examples of that, because that is the only way that you will lose your hand, and you will be able to perform quadratic formula without fear and with very precise precision. X squared plus 3x plus 4 equals 0. So you know the leading coefficient is 1, and the quadratic formula is -b plus minus the square root of b squared minus 4 times a times c, and all over 2 times a. 2 times a. So let's label my numbers to replace these numbers for the letters in the formula. My 1 is a A, my positive 3 is a B, and my positive 4 is a C. So let's start working in this assignment. Okay. So let's start working in this assignment. I will start with my B. My B is 3. It will be minus positive 3 plus minus the square root of 3 minus 4 times 1 times 4 all over 2 times A, that is 1. Let's start cleaning this equation. Negative and positive is negative. It will be negative 3 plus minus, no, the square root of 3 squared is a 9, minus 4 times 1 is 4, and times 4 is 16. Yep. And times 4 is 16. So let's start working this and everything over 2. So let's simplify one more time. Negative 3 plus minus the square root. 9 minus 16 is negative 7. All over 2. We know the negative 7 have not a square root, and there is no way to simplify this in lower term because 7 and 3 are prime numbers. When you have a prime number in any part of a fraction, that is the end of the game. If you have to solve this without using decimals, something like that. So we can separate this in 2 ways, no? We can have the negative 3 halves, no, plus the square root of 7 over 2. That will be one answer. And it's a negative 3. Negative 3. Don't forget it. Oh, I had the negative already. So I'll put this negative here. Or negative 3 halves, no, plus minus the square root of 7 over 2. So that is the 2 answers, and that concludes our video of the quadratic formula. I hope you have enjoyed this video as I enjoy doing math, because math is a lot of fun. Well, until the next video, God bless you and enjoy your weekend. Bye-bye.